Welcome to the fourth video on combined stress. In this one, we'll use the equations that we've determined for the stress distributions, and we'll sum them together for specific points. In this video, we'll do point A, which is at the top. We want to determine the stresses at point A and B. Let's consider point A first and go through all 6 of these equations. First, these green ones that are the normal stresses, and then these blue equations which contribute to the shear stress at A. So our normal stress at A is going to be a sum of all 3 of these. That first one, very easy. Normal stress in the x direction at A is going to be equal to 381.97 psi. That's not a function of location, that's a uniform distribution. Very good. Minus, now this one. For this one, y is in this direction. So y is going to be 1 inch, because we've got a 2-inch diameter cross section here, and that's z. So this second equation is going to contribute, and it's going to be negative 4,586 pounds per cubic inch times 1 inch. And then there's this equation. Now this equation, we're going to say minus 3,057 pounds per inch cubed, but z for A, if you look, is 0. So that can just go away. That's 0. There we go. So summing these two together, we obtain negative 4,204 psi for the normal stress at point A. Now for the shear stress. For the shear stress, well, I guess we can do the torsion equation, but we're going to need Q and T for this. So for a semicircle, so for xy, this is going to go to 0, right? Q has to be 0 because we're not going to be, we're refilling in from the top down. That's 0 at A. However, if we look at a, what's the color? I guess red. If we look at our shear in the z direction, Q is going to be this whole space here. And so it's going to be the centroid of that about this point right there. It's A times y, or in this case z, and that's going to be pi times 1 inch squared times the location of the centroid is going to be 4/3 times pi times the radius, which is 1 inch. So that's going to become, those pi's cancel out, very good, very good, very good. Those become 4/3 inches cubed. Oh, sorry, it's only half a circle. How silly. So it's going to be 2/3 inches cubed. All right. So now we've got Q down. T will obviously be when we're taking it from this point to this point. So when we examine the shear stress at A, it's going to be XZ, because it's going to be orthogonal to this X direction, and also along this Z direction. It's going to be equal to, first, this torsion portion, which will be in this direction, so negative, we'll call it negative 1,591.5 pounds per cubic inch, multiplied by our 1 inch radius from the center of this up to A, plus this one we said would go to 0, so I'll just pop a 0 in there, and then it'll be 509 pounds per inch to the 5th times 2/3 inches cubed, and then divided by 2. And I put the inches for that right there. Altogether, when we sum all this together, we're going to end up with negative 1,421.7 psi. Note that the torsion of this is going to cause negative shear stress, but the applied shear is going to cause positive. Right? If we look at we've got positive torque, which means that at the top, the shear is in the negative direction, right? So be very careful about that when actually doing these problems, because if we had another point, let's call that, C, I guess, is the one that makes sense, then this value would be the same from the applied shear. It'd be the same. But this value would be the opposite. It would be in the opposite direction. And so they would sum together to be much larger, something over something over 2,000 psi of shear stress right there. So do be careful of that. Now let's consider point B.